Hello guys, today we're going to apply our knowledge ka dissecands and tangents to biology in a So we're going to apply the concept here, a slope of a secant and a slope of a tangent. And we remember, we could recall hore a slope of a secant it wants an average rate of change, whereas the slope of a tangent you want an instantaneous rate of change. And now we're going to see how we could apply all this to a case study in biology, right? So naturally, let us just look at the paragraph we have here. It is explaining what we already know. The slope of a secant is an average rate of change, ne? And then, well, we have a lot of notations here, but in a nutshell, average rate of change in f, where f is y, right? And then change in t, where t is x man, x existing. So we are talking about a function of time, right? So average rate of change vertical change kappa change in y over change in x in horizontal change. This is not a new concept. We have done this before. Really, our focus right now is in this example that we have right here. So we have an example here. We call it doing milk temperature. We're in the process of making yogurt. So this is milk temperature and a recipe for yogurt. So this is what essentially basically is being done. How is a yogurt? To make yogurt, you heat milk to 190 degrees Fahrenheit to kill bacteria, then cool to 110 degrees Fahrenheit, and then afterwards you add a spoonful of live or pre-made yogurt and keep the mixture at 110 degrees Fahrenheit for 7 to 8 hours. This promotes growth of the microorganism lactobacillus that turns milk into yogurt. Okay, this is a case study. Even though it's detailed, a spoonful of live bacteria, it doesn't matter. What matters is the information that we have here. Calculator rate of change. All right, so what happens here is when time is 0, the temperature is 44.3 degrees Fahrenheit. This is in the process of heating up the milk, right? And then how qetile ho heata milk you heat it 44.3 degrees Fahrenheit and up to 186 degrees Fahrenheit. Or even this data is collected in this time interval. And then we have cooling milk. This is when you start cooling milk, it will try which is 190 degrees Fahrenheit, like we said here, and we want to cool it down to 110, but time intervaling in at after 26 minutes, 111.2 degrees Fahrenheit. Remember, 110, but it doesn't really matter. So what you are supposed to do is to draw a graph on the same pair of axes. You draw the graph representing this table, and then it will try a. And then after, the space is provided in your workbook. Hausner workbook, you can use you can pause the video and plot on your square book or whatever. Just plot the graphs, and now this is where it becomes interesting, but this is where our focal point is. Now we are supposed to calculate the average heating rate and cooling rates respectively for time interval ya 2 to 4. How do we do that? What you're doing right now is to find the slope of a second between the points 2 and 4. So we're going to calculate the average rate, the average heating rate and the cooling rate respectively. I'll give you a minute, or you can even pause this video and then continue to see if you are in the right direction. Okay guys, so we are doing, let me check the question asked you to, the question asked you to find the average heating rate and cooling rate respectively. So we're going to start with the average heating rate. The average heating rate, what you do is to look at a time t temperature in bukai, and in this case our temperature is a function of time, right? So we see from our table that when T is equal to 2, then temperature is equal to 108 degrees Fahrenheit. And when temperature is equal to 4 minutes, our temperature is equal to 161.9 degrees. So what we are doing here is to calculate the slope of a line that joins the 2 points, 2,108 and 4,161.9. So the average heating rate then would be 26.95 degrees. What does it mean? It means that between time 2 minutes and time 4 minutes, the heat increases at the rate of 26.95 degrees Fahrenheit per minute. It means that between the time interval of 2 and 4 minutes, the heating rate is equal to 26.95 degrees Fahrenheit per minute. Ka mantswe a mang motsotso le mo ha fela nako ile dipakeng tsa 2 and 4 minutes, motsotso mo le mong, our temperature increases by 26.95 degrees. Jwale our average cooling rate ke ena he. Ho tlo sheba tableng ya cooling rate, wa bona hore he when T is equal to 2, your time is equal to 176. And then when T is equal to 4, your T is equal to 164.6. Ebe he, your average cooling rate is equal to 176 minus 164.6 over 2 minus 4. And then this gives you minus 5.7 degrees. This means that when the time is between 2 and 4 minutes, the milk temperature decreases by 5.7 degrees Fahrenheit per minute. So how do you graph how your second lines for both graphs? You will be able to see how average cooling rate how slope sifting on your curves. Okay, so I encourage you to draw the curves so that this sticks with you. Hobane potso e ka hla ele graphical kapa ele algebraic, right? And we continue. Right, okay. When we continue, we are going to look at the instantaneous rate of change. Remember, to calculate the instantaneous rate of change, we have to calculate what? A slope of a tangent. And by definition, a slope of a tangent is equated to the limit as h approaches 0 of this. And this is something that we have done in Harriet's introduction to calculus using the tangent problem. Okay, so now we have an application in biology. We want to calculate the instantaneous rate of change of a model. So the model that we have, Kiena, and the heading key exponential growth. So we say we start with one cell hypothetically and put it in a minimal medium where it and its daughter cells will grow and divide once every hour. So they divide. So the hypothetical situation is graphed or modeled by the graph that you see here. So ebile in the equation again, y is equal to 200 e to the power 0.02. Now what you are requested here is to calculate the instantaneous rate of change at t is equal to 20, and then t is equal to 60, and at t is equal to 120. Before we attempt this question, let us discuss what we have to do. Remember, you are calculating the instantaneous rate of change, and we said that the instantaneous rate of change is a slope of a tangent. And you shall recall that a slope of a tangent to a curve at a specific point again is a derivative. So this says to us that you're going to compute the derivative for this function, and then for different points you're going to substitute t for 20 or 20 for t, and then 60 for t, and then 120 for t respectively. So I'll give you, or you can give yourself a minute by pausing and finding the derivatives, and then just a derivative. After finding the derivative, you're going to substitute 20 for t, and so on and so forth. You can pause and see if you're going to get it right.